Hi there, this is Tim Long from Tiger Astronomy, and in this live stream today I'm hoping to cover a little bit of information about how to develop your own transaction classes if you're using our Reactive ASCOM communications library. And I've just been working with someone today to help them do this, and it became obvious to me that some of the concepts aren't as clear as perhaps they could be. So is just develop a transaction live and talk through what I'm doing and some other rationale behind it. So okay, so if we just transition over to Visual Studio, here we go. You should be able to see my code now. Now I've already done File New Project, and I'm not using a template or anything, but I have already brought in the Reactive Communications library using NuGet. So you won't have to wait for me to do that. And I've created this skeleton code, which is a console application, and it's very similar to the demo code that's included in the source code for the Reactive ASCOM library. So it should be familiar, but I'll just quickly talk through it. So first of all, we have a connection string which tells us the communications parameters for the device that we're using. Now I'm using the AWS drive system. I don't know if you can see that. It's giving a readout of coordinates, and this is the intelligent handset for the drive system. And it's connected up to a drive box with just some motors on the bench here. There isn't actually a telescope connected or anything. This is the system I use for development. But what I'll do is I'll load up PuTTY, which is a terminal emulator, and I will connect up to that. Let's bring PuTTY over here. Okay, and then so we can send it commands, and it uses the protocol is based on the Mead LX200 protocol. So every command starts with a colon and ends with a hash or pound sign, as you Americans like to call it. And immediately you type the hash character, you get the response back. So that's kind of small. I hope you can see it, but I typed in GVN, which is get version number, and the result V1.730 came back. Okay. Now what I'm hoping to do for this demo is to show how I would develop a transaction to get the date from the drive system. So the command to get the date is GC for get calendar date. So colon GC hash, and what we get back is 04/22/17, so April 22nd, 2017. And that obviously is in United States short date format with the month first and the day second and the year last. And one of the wrinkles here is that I'm in the UK and we generally write our dates with the day first, so we would write 22/04/17, so I need to cope with that culture sensitivity when I'm writing the code, so we'll keep an eye out for that. So let's just close PuTTY to free up the serial port. Okay, so these are our comms parameters. This will be different for every device, and there's enough flexibility in these connection strings for you to specify pretty much anything. So we start with a connection string, which is just a string. From that we make an endpoint, pass that endpoint into a serial communications channel. The channel goes into a transaction observer class, which is kind of the inner Reactive ASCOM library, and then we create a reactive transaction processor, which is a thing that we can feed transactions to. So this is once you've done the setup, this processor variable will be the thing that we interact with. Okay, the transaction processor needs to be subscribed to the transaction observer, or is it the other way around? The observer needs to be subscribed to the processor, and then finally we need to open the channel. Okay, that opens the serial port and everything gets going. So that's the setup. That's just kind of a one-time that you need to do once in your app, and then when you're done, you clean everything up by just disposing the transaction processor, and that closes the channel and everything internally. Okay, so we need to do this middle bit, which is to implement our new calendar date transaction and use it to get the date from the drive system. So, first thing I will do is I will just take that comment away, and I will start by saying var transaction equals new calendar date transaction. Okay. Oh. Just decided it doesn't like me. So unfortunately, sometimes I'm using a 7-year-old computer and it's a bit under-resourced, and we're going to get these hangs. And I'm doing this as a live stream, so everything that happens, warts and all. And I think that's much more realistic than some nice edited video and you don't see all the things that go wrong. So let's press on. Calendar date transaction. And generally in a transaction you pass it in the command that you want to send. So I'm just going to hard code it for our purposes. So get calendar date hash, and I'm going to leave the timeout, which I think defaults to 10 seconds if I remember correctly, but I would have to check that. But the default is usually more than enough. Okay, so obviously we don't have this class at the moment, so I'm going to use Resharper to create it. If you haven't got Resharper and you do any amount of development at all, I would strongly recommend getting it. It's a fantastic add-in for Visual Studio. Okay, so class calendar date transaction. Okay, now Resharper has automatically put in a constructor for me, so we're going to take a string which is the command that we want to send, and then we don't want to throw this exception. What we want to do is just pass that. Okay, so we need to inherit from a base class, so we need to inherit from all transactions in Reactive ASCOM ultimately inherit from this base class called device transaction. It's an abstract class, you can't new it up, you have to inherit from it, and then when you do inherit from it there are some abstract methods that you have to override. So if I just delete this constructor altogether and let Resharper do that for me, just implement missing members, and the two things that we must implement here are the constructor and the observe response method. So we'll finish and let Resharper do that. Okay, now it's created just the minimum constructor for me, which is just to pass the command parameter down to the base class, and the base class handles sending the command and wiring everything up, so that's more than good enough for what we want. The observe response method is really the heart of the transaction system, and this must be overridden in every transaction, and throwing not implemented exception won't really cut it, so let's do a proper implementation. Okay, so your observe response method has to do two things. It takes this source parameter, which is an iObservable of char, and you should think of an iObservable as a sequence of whatever brackets. So source will be a sequence of characters, and these are the characters that are received by the serial port. So we need to take that sequence and slice and dice it into something that we can understand, and we should filter out all invalid data so that we only receive responses that are correct for this transaction. For that reason, I'm going to name transactions after the type of data they'll be processing. So calendar date transaction obviously receives calendar dates, and I will make sure it can only receive calendar dates and nothing else. So alright, now a bit of preamble here. I need to set up a way of recognizing a correct date. Now, I like to use regular expressions for this, because regular expressions are really powerful for recognizing patterns and parsing data. Now I'm not going to use it to do the parsing in this instance, but normally I quite often do that, but I'm just going to paste in a couple of lines that I've got in a snippet here. And well, ReSharper doesn't like that, does it? We've got too many of those, and then it's all gone unformatted. So observe response. So that's the end of it. Observe response. That's the end of class, and that's the end of the namespace. Okay. So so what's wrong here is I can't put constants inside a method. That's crazy. So let's cut those out and put them up here at the top of the class. Okay. So the date pattern is my regular expression. If I use ReSharper here to mark this as a regular expression, and I can also validate my regular expression, and if I drag that window over, ReSharper's brought up my regular expression in a regular expression validation window, and I'm conscious that I need to take my oh no, you can see it. Okay, so this allows me to put in test input. So if I put in 1/45/67, this actually gets matched, curiously enough. So what I would have to do here is say this is the start of the string, now it no longer matches, and this is the end of the string. Okay, those are called anchors in regular expression language. Now if I take that one off, I now get a match here. So 2, 3, 4, 5, 6, 7 matches, but 1, 2, 3, 4, 5, 6, 7 doesn't match. So the regular expression here says 2 digits, D \D means any decimal digit. The thing in squiggly brackets here is a quantifier, so that means 2 of the previous thing, so 2 decimal digits, followed by a literal / character, and then another 2 decimal digits, followed by a /, and then another 2 decimal digits, followed by the end of the string. Okay, and as we can see, this very, very rigorously matches the type of string I need. Okay, and then having done that, having got everything correct, we can just click insert, and ReSharper puts that back in the code for us as we've edited. So that is our date pattern, and then we need to new up an instance of the regex class which uses the pattern just defined. I'm going to give it a regex options.compile so that it compiles the expression, and that just makes things work a bit more effectively at runtime because it only compiles the expression once. Okay, now then, now that we've got our regular expression, oh, one more wrinkle. I said I needed to be careful of culture sensitivity because the date we're getting US format and I'm in the UK, so I need to be careful with that. Otherwise, if I try to parse it, I will get the wrong thing. So I'm newing up here a instance of datetime format info, which I'm calling AWR date format. In fact, I will call it US date format. Why don't we do that? And that gets the datetime format from the ENUS culture object, and we'll use that later on in the code. Okay, now, so in our observe response method, we need to do two things. First of all, we need to filter this source sequence into strings that we deem are valid for our transaction. So the standard way of doing this is with a link query, language integrated query. Now normally you think of link queries as working on databases or collections of objects, but with the reactive extensions you can actually query sequences of data you haven't received yet. So it's basically kind of saying wait for this and then give me the value. So if we start by saying let's sequence. Okay, sequence equals. Now I'm going to use link comprehension query. So from strings in source dot. I'm going to use an extension method that's provided by the Reactive ASCOM library called. Can you actually see what I'm typing? Yeah, not. Let me just reduce my thumbnail size a little bit. There we go. So I'm going to use an method from the Reactive ASCOM library called Terminated Strings. Okay, Terminated Strings. And what that does is, as the comment here says, produces a sequence of strings delimited by the specified Terminator character. And the terminator here, char terminator equals hash, so it defaults to the hash character. I can put that in, but the moment I put it in, you see it kind of goes a bit dim, and that's ReSharper telling me that I'm actually using the default value, so I don't need to specify it. But we'll leave it there for now. Now, having sliced the character sequence up into strings terminated by a hash character, we now have a sequence of strings. So the next thing I want to do is remove the hash terminator, because that's not really part of the payload, that's just kind of protocol encapsulation. So I'm going to declare this intermediate variable called payload equal strings dot, and I'm going to trim end. Wait a minute, reactive link is missing, it says, so let ReSharper import that for me. Trim end, we'll take the hash character off the end. So now we've got a sequence of strings but without the hash characters of every string. And now I'm interested in, out of those strings, potential strings that I could receive, I'm really only interested in ones that are a valid short date format. So this is where my regular expression comes in. So I'm going to select a subset of the available strings using a where operator. We're only interested in the strings where they are validated correctly by our regular expression. Date regex dot is match payload. There we go. So where the payload is a valid date, basically, we're going to select that as a response. Okay, and literally we select payload. This concludes our link query. Now, out of that, remember that link queries are actually stored as expression trees, and nothing gets executed yet until they're needed, until you need to manifest materialize the result. So we haven't actually created this query, we've just defined it. But there's a bit more we need to do. We need to, this sequence as it stands will just sit there forever looking for date strings from the serial port, and every time it sees one it will emit that in its output sequence, but the sequence will never terminate, and so our transaction ultimately will time out and fail. So I also want to get some diagnostics on this so that we can see what's happening. So what I'm going to do now is take the sequence that we've defined and use this trace extension method, which again is defined in the Reactive ASCOM library. And we just need to give this a name which identifies it in the diagnostic output. So I'm just going to call it calendar date transaction. Okay. And then we need to limit the sequence to only producing at most one result. So that's done in link with a take operator, take one. So this means that as soon as our sequence produces a valid date, the sequence will terminate. And that's important for the way Reactive ASCOM works. So all transactions have to have that in there. And then the final thing we need to do is subscribe to the observable sequence and tell the reactive extensions what to do when the sequence produces a result, what to do when the sequence completes, and what to do if there's an error. So luckily that's all defined by the device transaction base class. So you just need to subscribe, give it on next, error, and on completed. Come on. On completed. Now these, that's, come on, end of statement. Okay, so these three action methods are defined in the device transaction base class. They're a lot of the time they're enough, and in fact I will leave it like that for the time being, and we can probably try the code at this stage. So if I save the ReSharper, will want to clean that up for me. There it goes. And if I right, so first thing is, let me just move this out into its own file. So that's two keystrokes with ReSharper, and there it is in its own file. So okay, now in the program itself, in the main method, we've now got that transaction class. We can now commit the transaction. So remember, we use the transaction processor to do that, to commit the transaction. And then we need to wait for it to complete. So that's transaction dot wait for completion or timeout. And then, as just for diagnostics, I will write it out to the console. So you can just write the transaction, and that's got its own method, so it will just come out nicely. There we go. Okay, let's run that and see what happens. The drive system is connected and powered up. I'm going to use, if I just get up the ReSharper tools, build and run, and that's come up on my other screen, so I'll just bring that in and park it at the bottom there. Okay, now that gives me a couple of useful things. It gives me a nice visual representation of the build, and it gives me a run button that I can just click to run the code without starting the debugger. So that's it. And you can see, you probably can't see it, actually. Ugly Mug's probably in front of it. That's me out. And you can see that the project that's being built is pulsating in green here at the bottom. When the whole solution is built, the top thing will go green as well, and then we'll know we've got a successful build. slurp of my while we're waiting. I remember coding at university in COBOL and having my code on a floppy disk and clicking compile, and the disk would launch away, and you'd literally have time to walk off and have a cup of tea and come back, and if you were lucky your compilation might be finished. So Visual Studio by comparison is a bit of a dream really. So there's no pause in a live stream. I did say you were going to see warts and all, and the compilation can sometimes take a little while. My computer, as I may have already said, is about 7 years old. Probably more than that now. It's valiantly trying to cope with Windows 10 and Visual Studio 2017. I need a new one, but it's not doing a bad job. I should fade to some music at this point. Good grief, this is taking a long time. Build succeeded. Green build. Okay, that should run now. And there we go. Okay, so let's have a... Oh, you can't see that because it's on the wrong... So here we go. The transaction pipeline got connected to the serial port. The channel opened. Serial receive subscription happened. Then we got transaction ID 1 got committed with our :gc command. It says failed here, which is something I plan to change in a future version. At the moment, transactions are always failed until they're successful, and I think it would be handy to mark it as pending or something rather than failed. So now here is the calendar date transaction subscription being created. Now that comes from, if you remember, if I can get the code up, we put in here a trace operator, and as its name we use the name of the class, so calendar date transaction. So that is where that diagnostics is coming from. This says that our observable sequence is being subscribed to. In the right, okay, so the command got sent by the serial communications channel. Then we see characters being received on the serial port. So the on is called for every character that we're receiving on the serial port, and there's our date string coming in, followed by the hash character, and then we get our calendar date transaction sequence emits an element. Its on next method gets called, and it's emitting is 04/22/17, which is our whole date string, and then we see that our transaction was successful. This is the console.write line in the program code here. This line here, 37, console.write line transaction, produces this line of output here, and we see that it was successful, and this is the result that it received.